Whole numbers.
Counting numbers are called natural numbers. Least natural number is 1. Greatest natural number does not exist as there is no n for the natural numbers. Natural numbers are denoted by n, that is equal to 1, 2, 3, 4 and so on. Natural numbers included with 0 are called whole numbers. Whole numbers are represented by w. W is equal to 0, 1, 2, 3, 4 and so on. Least whole number is 0. The greatest whole number does not exist as there is no n for whole numbers. A number which comes after a given number is called its successor. Successor is equal to given number plus 1. A number which comes before a given number is called predecessor. Predecessor is equal to given number minus 1. Place of a digit in a number is given by reading on different places according to the place value chart from left to right. The place of 7 in 34,782 is hundreds. The place value of a digit is given by seeing the digit in the particular place and then its value. The place of 7 in 97,632 is 7 thousandths. The face value of a digit is the value of the digit irrespective of its presence in any place. The face value of 7 in 37,489 is 7. In 9,387, the place value of 7 is 7. Properties of number. Closure property. When two numbers are operated in a set of numbers, either n or w or any set, the result should belong to the same set, then the closure property is said to be satisfied. A, b belongs to the number set. A asterisk b belongs to the number set. Asterisk operations can be addition, subtraction, multiplication or division. The closure property is satisfied in sets of natural and whole numbers with respect to addition and multiplication. Associative property or grouping property. When three numbers are being operated, if the result remains the same, even when the grouping of the number is changed, then the numbers are said to be associated with each other with that particular operation. A, B, C belongs to the number set. A asterisk B asterisk C is equal to A asterisk into B asterisk C is equal to C asterisk into B asterisk A. Associative property is satisfied in sets of natural and whole number with reference to addition and multiplication. Commutative property or order property. When two numbers are operated, the result should remain the same irrespective of the order in which they are operated. A, B belongs to the number set. A asterisk B is equal to B asterisk A. Commutative property is satisfied with reference to the addition and multiplication in natural and whole numbers. Distributive property. The two types of distributive properties are multiplication over addition and multiplication over subtraction. If A, B, C belongs to the number set, A into B plus C is equal to AB the whole plus AC the whole. A into B minus C is equal to AB the whole minus AC the whole. Distributive property is used to find the products of large numbers. Identity element. 0 is the identity element with reference to addition for natural and whole numbers. A plus 0 is equal to 0 plus A is equal to A. 0 is the helping element to retain its identity. 1 is the identity element with reference to the multiplication for any natural numbers. A into 1 is equal to 1 into A is equal to A. Number line. A line on which we locate numbers. The gap between the numbers should be equal. Properties of addition. Closure property. If A and B are any two whole numbers, then A plus B is also a whole number. Example, take 5 and 13. 5 plus 13 is equal to 18, which is a whole number. Commutative property. If a and b are any two whole numbers, then a plus b is equal to b plus a. Example, 3 plus 11 is equal to 14, that is equal to 11 plus 3. Additive identity. If a is any whole number, then a plus 0 is equal to 0 plus a is equal to a. 0 is called the identity element for addition. Example, 9 plus 0 is equal to 0 plus 9 is equal to 9. Associative property. If a, b, c are any three whole numbers, then a plus b the whole plus c is equal to a plus the whole of b plus c. Example, 2 plus 3 the whole plus 4 is equal to 9, that is equal to 2 plus the whole of 3 plus 4. Properties of subtraction. If a and b are two whole numbers such that a is greater than b or a is equal to b, then only a minus b is a whole number, otherwise it is an integer. If a and b are two whole numbers such that a is not equal to b, then a minus b is not equal to b minus a. If a is any whole number, then a minus 0 is equal to a, but 0 minus a is not defined. If a, b, c are three whole numbers such that a is not equal to b, not equal to c, then a minus b the whole minus c is not equal to a minus the whole of b minus c. Properties of multiplication. Closure property. If a and b are any two whole numbers, then a into b is also a whole number. Example, take 3 and 5. 3 into 5 is equal to 15, which is a whole number. Commutative property. If a and b are any two whole numbers, then a into b is equal to b into a. Example, 4 into 12 is equal to 48, that is equal to 12 into 4. Multiplicative property of 0. If a is any whole number, then a into 0 is equal to 0 into a is equal to 0. Example, 2 into 0 is equal to 0 into 2 is equal to 0. Multiplicative identity. If a is any whole number, then a into 1 is equal to 1 into a is equal to a. 1 is called the multiplicative identity for whole numbers. Example, 7 into 1 is equal to 1 into 7 is equal to 7. Associative property. If a, b, c are any three whole numbers, then a into b the whole into c is equal to a into the whole of b into c. Example, 3 into 4 the whole into 5, that is equal to 60. That will give you 3 into the whole of 4 into 5. Distributive law of multiplication over addition. If a, b, c are whole numbers, then a into the whole of b plus c is equal to a into b plus a into c. Example, 5 into the whole of 6 plus 7 is equal to 5 into 6 plus 5 into 7 is equal to 65. Distribute law of multiplication over subtraction. If a, b, c are whole numbers, then a into the whole of b minus c is equal to a into b minus a into c. Example, 2 into the whole of 4 minus 3 is equal to 2 into 4 minus 2 into 3 is equal to 2. Properties of division. If a and b, that is non-zero, are whole numbers, then a divided by b is not always a whole number. If a is the dividend, b, where b is not equal to 0, is the divisor, q is the quotient, and r is the remainder, then a is equal to bq plus r.